Today, we are going to do something extra special since I'm having such a peaceful day out in outer space. We are going to talk about the different types of machine learning out there. And in particular, I am pleased to share with you that we are going to be reviewing my patented machine learning visualizations. Now, the key thing to know about my patented machine learning visualizations is they are not patented, but I hope they're helpful. So, a common way to think about machine learning is as three different types. So, we have supervised machine learning, unsupervised machine learning, and something called reinforcement learning. Supervised machine learning is when we have both inputs and outputs. We have both an X and a Y variable, and we are going to train our data on the relationship between the two, and then we are going to make a test, and then we are to see how good we are, and then we're going to make predictions. So examples, annual promotion scores. So suppose I have inputs, how many sales you had, how many promotions you gave out, whether or not your colleagues like you in your 360 review, and then your prediction, your Y value would be whether or not they were promoted in the years prior. So I have this whole data set of things about the employee each year, and then whether or not they were promoted. Why don't I make a machine learning model to predict whether or not to promote someone based on these inputs? Now, there are a number of problems with this. Happy to chat about it in the comments. We could also use supervised machine learning to predict top songs on Spotify. Maybe I have a data set of things about the song, who the artist is, how long the song is, what genre of music it is, whether it uses certain words, whether it has a certain style, and then predict whether it was in the top 10 or what its rank was or whatever else. Spam filters in your email is another example of this. The two major types of supervised machine learning are regression and classification. Unsupervised machine learning, now we're getting wild, is where we have only inputs and then our computer finds structures based on the data. It might find clusters or categories based on similarities. I'm going to walk through some more specific examples of this, but we'll keep it high level for now. So what's going on here is the model is learning the relationship between the variables. And in this case, our variables are only X variables. So what we might have is a bunch of data on, say, customers to our business. And we say, I know all this stuff about the customers, how much they spend, how often they visit, whether they tell their friends, do they interact with our social media posts, what sorts of things do they buy, what are the reviews of our products, But I don't have any prediction about those customers. If I said, if I want to predict how much each customer is going to spend, I have my X's and Y's, we're back in supervised. But I maybe don't have any of that, or I actually want to do it in terms of unsupervised machine learning. I would just look at all those attributes and say, okay, could I draw some clusters in my customers? And I've seen companies do this, and I think to great effect. You say, okay, I could segment my customers in terms of like ultimately loyal customers, take it or leave it customers, deals only customers, or whatever. So the computer would help me find natural clusters in the data of the types of customers that I have. And then it's up to me to decide what that means. It's a little bit like computational reading of tea leaves. And I mean that in an actually flattering way. I find unsupervised machine learning to be very fun. My students tend to find it unsatisfactory. Semi-supervised machine learning lies right there in the middle, where we have input data and some output data. Reinforcement learning, just to compare it to the other two right here, is when inputs are given and then the model is rewarded or punished based on the output. It evolves based on trial and error. It's quite different from supervised and unsupervised in terms of its approach. So some examples of reinforcement learning are if you're following stories about AI playing games such as AlphaGo Zero, following anything in the world of robotics, self-driving cars, maybe automatic online stock trading, a lot of that has reinforcement learning in the background, and we'll talk more about that to come. So a few example applications of each kind. For doing regression, we might be predicting housing prices, sea levels, COVID infections, or we could do classification if we're predicting a category. So is this transaction fraudulent or not? Is this a spam email or not? Unsupervised machine learning, two big types generally. One is clustering. We're breaking down our observations by common features, and we'll talk more about this in the next video. So in biology, we might use unsupervised ML to group observations of creatures we see somewhere into species. Medical imaging might use it to detect different types of tissues. I see it in the business world as far as targeted marketing. I want to differentiate different groups of customers. I don't have labels for those customers, but I have a lot of data about my customers, and I want to see what maybe some of the natural clusters might be, and my computer is going to help me do that. Or anomaly detection. Another one that we won't talk about in this course, but you will encounter in later data science work is dimensionality reduction. This is when you have tons and tons and tons of attributes. So it's all about distilling relevant information from, say, thousands of variables. And some examples include feature extraction, where we merge correlated variables into just one variable. This is at the backbone of a lot of facial recognition and text analysis. And then finally, reinforcement learning. There's gaming, there's manufacturing, there's robot navigation. Another application kind of different from building robots that do stuff is testing hypotheses in cognitive science, and of course, this guy. All right. Just a little bit of fun with reinforcement learning. We'll visit it in the, not the next video, but the one after that. This is from Boston Dynamics. I don't know for sure how they build their robots, but I would put a decent amount of money that there's some reinforcement learning in there, where you give some inputs and then you reward the machine for learning to behave in certain ways. If you're thinking about analogies of raising children or training dogs, you're spot on. So let's visualize how supervised machine learning works in our computer. If you want actual code for how to carry this out in Python, please check out our free online textbook. This is known as bivariate or simple regression. This is the way that we would go about setting up our machine learning algorithm in Python or in something else to do a machine learning approach to regression. Here's my not so patented image. I hope these diagrams are helpful. So I have two variables. I have my X variable and my Y variable, or my input and my output. Let's suppose I'm setting my test size to 0.2. More on that in just a moment. All right, so the first column here, this represents my variable in my data set. I have my X variable, also known as the IV, the input, the attribute, or the feature, and I want to predict some output variable, outcome result, DVY, depending on what training you had and what language, what set of terminology works for you. So our data set is depicted in blue. So again, think of this as the columns in like an Excel spreadsheet or a Pandas data frame. Our data is here in blue, and we're going to divide our data into a train and test set. So the training set is the one that our model is going to learn from. Once we've trained our model on the data that we've gave it about the relationship between our X and Y, our input and our output, we're going to say, okay, computer, I've got the test set over here. You make your predictions based on what you've learned, and then I'm going to compare it to the test and see if you did a decent job. So I've set the test size to 0.2. You can set it to something different. Students always want to know, how do I know what to set the test size to? The answer is you don't. You try a number of different ones. You could sweep the parameter space, but there's no hard and fast rule for what. It depends a lot on what you're doing and what you're trying to understand and your tolerance for errors. Aha. So why am I doing all of this? I'm doing this because I anticipate getting new data. This is in green. That's going to be my new input data. And I hope to predict my new output data over here. So I'm going to make some prediction. That's a number. So to make this more concrete, we did the case of cigarette taxes and smoking rates in the statistical approach to regression several videos ago. Let's talk about how we might set this up from a machine learning approach. So what we would do is we'd say, okay, I have data on the cigarette tax in each state in the United States. Is it $1? Is it $2? Is it $3 per pack? I also have historical data on the smoking rates of people in that state. Is it 4%? Is it 12%? Is it 30%? What percentage of people in that state are smoking? I train my model. Hey, here's the cigarette tax in all these states over time. Hey, here are the smoking rates in all those states over time. Then I'm going to say, hey, here's the test data where I'm going to give you just the cigarette taxes, and you are going to predict the smoking rates, and I'm going to see if you're right or not. I'm the sneaky professor evaluating you. And if I'm satisfied with it, then I say, okay, bring on new data, new cigarette tax data, and I will predict what the smoking rate will be in that case. If we are doing the same thing, but with multiple independent variables or multiple regression, it looks the same. We just have more X variables. In this case, we might have cigarette tax, the number of cigarette ads, and the allowance of indoor smoking, and then we'll predict the smoking rate. So same sort of thing. Note again, this is not multivariate regression. That is when there's more than one outcome variable, and we are not touching that in this video or this course. So to test your understanding and just to see some intuition, work out, pause the video, and think through how might the following examples map to a supervised ML multiple regression model. So suppose I want to predict apartment prices in New York City. So that's my Y. What might my attributes X1, X2, X3 be? Suppose I want to predict the percentage of people in a county who will vote in an election. What might my X1, X2, X3 be? One of the best ways to build an intuition for ML is to imagine how you would construct a model or how you would set this up. And so I really do encourage you to think it through. Now, if we're doing classification rather than regression, we are predicting, it's almost the same, but we're predicting a label. We're predicting a class. In this case, we're doing a binary or a two-class classification, meaning we are going to predict whether our data is A or B, 0 or 1. We're going to call this our Y variable, our DV, output, outcome, result. If we're doing classification, we might call it our class, label, or category. For example, we might have data on the location of someone's credit card purchase, and we might want to predict its class, fraudulent or not. Our outcome is binary. We could also do multi-class classification. This is where we are predicting a class that can take on more than two values. So it's not just a binary, infected or not, fraudulent or not. It's, in the case of email, is it spam or not? If you're using Gmail, you know that it classifies our email as primary, social, promos, updates, form, whatever. So multi-class classification, there are more than two outcome classes. Everything else is the same. And of course, we can have classification with multiple attributes. So in this case, we're just predicting a binary outcome, fraudulent or not, but we have multiple attributes. So another exercise, what's an example of a binary classification problem? The fraudulent or not, infected or not, what's an example? What might the attributes be in an ideal data set for the case you just thought of? What's an example of a multi-class classification problem? And what are the ideal attributes in a study for you? Again, imagining what you might do is a really good way to build intuition. So translating the world into data science problems is an art and a science, but you already knew that because I can't stop talking about things being an art and a science. I'm not going to talk through this here, but I wanted to share it because I do typically run a pretty long discussion with my students about how you might set up a model to evaluate these problems. They're all politically related because that's the sort of thing I think about. But the idea here is, hey, you're working in a real life scenario. For example, the first one, you work for a candidate for Senate and they say, hey, here's a whole bunch of data. Predict the outcome of the next election. Will they win the election, right? What do you do? What might be your dependent variables? Here are some ideas. What might be your independent variables? What type of model might you use? Would you do classifier, linear regression, and so on? I'm not giving you an answer because there is no right answer. There are answers that I would find more compelling than others, but there truly is no singular right or wrong answer, which frustrates students who come to data science looking for right or wrong answers. And it's not obvious how you would translate these interesting problems into data science models. But if it's helpful, go back to those images and see what you could fill in for these particular problems. And again, happy to talk about this with you in the chat or somewhere else on the internet. All right, so that's it for supervised machine learning visualizations. I will see you next time.